On Earth, human beings need oxygen, but in space, there isn't any. The International Space Station has several systems to produce oxygen and supply it to the crew.
The atmosphere on board the ISS is very similar to the atmosphere we have here on Earth. The only difference is we have quite a bit more CO2 on board the station. That's a real concern for the astronauts. So a big part of my job is oxygen generation. We have what we call an OGA, the Oxygen Generation Assembly. So it takes water, it's H2O, and uses electrolysis to split the hydrogen away from the oxygen.
Part of the oxygen is made in the Russian service module.
Here we are in the service module. It's not very big, but it's essential. This module contains all the systems needed for the cosmonauts to stay alive.
It contains reservoirs of recycled water through which electricity passes. This electrical charge isolates the chemical components of the water, hydrogen and oxygen. It's called an electrolyzer.
We can take that oxygen from the H2O and release it back into the atmosphere for the crew to breathe.
The oxygen is pumped through pipes that cross the station to provide the crew with fresh air.
So yeah, we can look at the constituents of the atmosphere and see how much oxygen do we have, how much CO2. Do we need to generate more oxygen? Should we be scrubbing CO2? Do we need to replace nitrogen? Are we leaking overboard? We have a lot of different data, what we call telemetry, that we're getting from this room.
Making oxygen is one thing, but the air cannot stagnate. So the space station has a network of top-flight ventilators.
And so if you don't have any ventilation systems or any fans mixing the air, essentially you would get pockets of oxygen and pockets of CO2. And in the worst case, for example, if you were sleeping and you didn't circulate the air, you could, in theory, generate a bubble of CO2 gas around your mouth and suffocate on it.
Water is essential on the space station to drink, to wash, and also to breathe. In the early 2000s, when the first crew moved in, water was delivered from Earth in pouches. Today, the supply cargoes still bring water, but not enough for all the oxygen production or water consumption of the astronauts. So more than elsewhere, water is absolutely crucial and must never be wasted. To compensate for the absence of gravity, the astronauts must do a minimum of 2 hours of exercise every day, so they lose a lot of water.
When we do sports, for example, we sweat. When we wash ourselves, we use water and we dry ourselves with towels. These towels you just hang up in the air like you would do at home, and naturally they will dry up.
And we leave those towels close to a ventilation grid, like in this case you can see a ventilation grid right here, so that they can dry off. And all the water then is recuperated. It evaporates in the air, and then in the air conditioning system it condensates again, and it goes into our water recuperation bus, and it actually gets turned into potable water again.
Saving resources is a constant concern, and even the laboratories help.
So urine gets recycled through a process that actually turns it back into potable water. So we drink our pee.
And it separates the water and the air inside there, the urine in the air. And the urine, of course, goes to the urine processor. The air gets a little bit filtered and sent back out again.
And today we have managed to recycle about 70% of all the water that is on board of the ISS.
Today, this complex water recuperation and oxygen production system guarantees a supply of water and air that is often even purer than we have at home. And managing waste recycling is also key for preparing for longer voyages.
We can take the CO2, we can take the hydrogen from the electrolysis, react that with the water to produce more water and more oxygen, and then as a byproduct we get methane. In the case of the space station, methane is a waste product, and so we vent the methane overboard. But it's a very interesting reaction because you could potentially use this very same reaction on Mars to generate rocket fuel for your return journey home.
I'm going to take you to one of the coolest places on the space station.
The place that everyone loves on the International Space Station is at the end of the Tranquility Module, the cupola. This dome, with 7 reinforced panoramic windows, always points towards the Earth, which is constantly passing. Traveling at a speed of 28,000 kilometers an hour, the International Space Station travels around the Earth 16 times a day. Its trajectory covers 85% of the surface of the globe and offers a prime observation post for scientific discovery. Within the framework of one of his experiments, Danish astronaut Andreas Morgensen is looking to film meteorological phenomena that are impossible to observe from the Earth.
And one evening after dinner, I was sitting in Cupola, and a gigantic thunderstorm started to develop. And so I took my camera and I started filming as much as I could. And it turned out that I was able to not only film some red sprites, but also a pulsating blue jet. So this cone of blue lightning that shot up from the top of thunder clouds. And that's something very new. It's the first time it's been captured on video like this. So potentially it could affect our understanding of climate change and global warming, because it's a mechanism whereby we can transport gases like water vapor from the troposphere into the stratosphere.
The cupola is also where the astronauts come when they have some free time.
I'm gonna miss that cupola, because I'd go in it every night for an orbit, and I would watch the Earth, and I knew that that was borrowed time. I wasn't gonna see that forever.
It's a haunting spectacle. You could watch the Earth for hours from the window because it changes all the time.
You tend to look big picture, and the longer you're up there, you start to narrow it down, and you start to pick out small bits of detail and start to identify places you might have visited or other things you want to look at.
When we go to other planets in our solar system, I think the moment when we can no longer see Earth through the window will be very stressful. Because for us on board the station, as soon as we have some free time, we always look back at the Earth.
In space, when they look at the Earth, the astronauts experience a unique feeling called the overview effect. It's an awareness of the place of Earth in space.
And your perspective changes with regard to this planet, which is so normal to us, so finite when you look at it from the ground.
The Earth is a unique organism. You can't see the frontiers of countries, but you can see the frontiers of misery. From up there, you can see the environmental catastrophes, the fires. And sometimes you get the feeling that the Earth is calling out to us for help.
It was like being in a movie where they might dolly a camera back, but zoom the lens in to where the actor, or in this case the Earth, doesn't change size, but your sense of reality around it just comes crashing down. And I had literally a physical reaction at that moment where you just kind of know, like, I get it. I just kind of get it in a way that I've never done before.